Today, this is for class 12. I have taken nuclear fusion. Why nuclear fusion? Because in your book, it has not been explained in spite of this Coulomb repulsion. That is the two light. What is nuclear fusion after all? That is the two light nuclei, they must come together, they must come closer so that the nuclear force it acts in small range so that the nuclear force can combine these two nucleus, that is two protons. Actually, what is nuclear fusion? Nuclear fusion is that two light nuclei combine to release energy. So two light nuclei, that means it is proton after all. So remember that in a nucleus, in spite of hi- high repulsive force, Coulomb repulsive force between proton and proton, because of this nuclear force, it acts in small range. Because of this nuclear forces, the all protons are intact inside the nucleus. So in your book, it has been not mentioned how this two nuclei, that means two light nuclei, that means two protons, they combine how. So in order to explain this, I have taken this nuclear fusion. So in nuclear fusion, you all know that two light nuclei, that means let us take hydrogen, uh, they combine to form combine and they release energy. So here you see the reaction, that means 1 plus this is two protons, they combine to form H1 plus E plus nu and around 0.42 mega electron volt. This is the where E plus, this is positron, this is positron, and nu nu this is neutrino, neutrino. This is given in your book, and it releases 0.42 mega electron volt. Now they have to combine, and these two light nucleus means the protons. So there is, you all know that there is a Coulomb repulsive force. That means these two nuclei, this is two proton, must overcome this Coulomb barrier. They must overcome this Coulomb barrier. Uh, they must overcome this Coulomb barrier. They must overcome this Coulomb barrier. Then only they will come closer, and the nuclear force it will combine them. So, and this repulsive force, it depends on this the Coulomb repulsive force. It depends upon uh, on the charge on it and its radii of the two interacting nucleus. It depends on it. So an example it has been given here in your book, that is the Coulomb repulsive force between two proton is round about, it is round about 400, it is round about 400 kilo electron volt, is round about 400 kilo electron volt. That is the repulsive force, that means this is the barrier. This is the barrier, which is also it is called as potential barrier. This is the potential barrier. Barrier. This is the potential barrier. That means to cross this potential barrier, this barrier, the two nuclei, that is the two proton, must have enough kinetic energy, greater than this kinetic energy, so that they come closer to each other. And for this barrier, we require temperature round about, we require temperature around 3 into 10 to the power of 10 to the power of 9 Kelvin. We require this much use temperature we require, so that the two protons gain enough kinetic energy and it can cross this barrier, and they come together and combine to um, they bind together and release energy. So this is given in your book. Now, what happens in a sun? Now the case is what happens in a sun. The core of this uh, sun, the interior temperature of the sun is round about the interior temperature, that is the interior temperature of the sun is round about 1.5 into 10 to the power of 7 Kelvin. 1.5 into 10 to the power of 7 Kelvin. This temperature is not enough. Uh, this temperature is not enough for the fusion to take place. This temperature is not enough to for the fusion to take place. This temperature take place. That means the two protons does not gain energy, kinetic energy, so that it can come closer to each other. This is the interior of the sun. No doubt it is very high temperature. This is 1.5 into 10 to the power of 7 Kelvin. But you have already, it has been told that the temperature is 3 into 10 to the power of 9 Kelvin to overcome this potential barrier. But here, the internal temperature of the sun is 1.5 into 10 to the power of 7 Kelvin. Yet the fusion, it is not enough for the fusion to take place. Not enough. This is not enough for the fusion to take place. So how the fusion happens? Now the question here is how the fusion happens. So there is this is explained by quantum tunneling. This is explained by quantum tunneling. Yeah, this is explained by, we call it quantum tunneling. Quantum tunneling. This is explained by quantum tunneling. Therefore, I have taken this subject, this nuclear fusion. Why? Because in your book it has not been given why. How? This is how this in spite the this in the sun the interior temperature is 1.5 into 10 to the power of 7 Kelvin. It is 1.5 into 10 to the power of 7 Kelvin. In spite of this, this temperature is not enough for the fusion to take place. So how fusion takes place? So this is not explained in your book. Fusion takes place because of quantum tunneling. This is called quantum tunneling. Now what is quantum tunneling? That is, a quantum particle can penetrate and pass through a potential barrier even if its kinetic energy is less than the height of the barrier. Even if the kinetic energy is than the less than the potential barrier. Even if kinetic energy is less than the potential barrier. This is quantum tunneling. Because of quantum tunneling, that is, a quantum particle can pass, that means it can penetrate through a potential barrier. That is, quantum particle, it can pass through a potential barrier even if its kinetic energy is less than the potential it can pass through it. This is called quantum tunneling, and this is explained by the quantum mechanics. This is explained by the quantum mechanics. So, I have already told you the interior of the temperature of the sun is this, and it is not enough for the fusion to take place. That means the proton, the kinetic energy, it does not gain so much enough kinetic energy so that it can overcome the potential barrier. What is the potential barrier? That is the Coulomb repulsive force. That is the Coulomb repulse. It can't overcome it. But because of the quantum tunneling, that is because of the quantum particle can pass through the potential, high potential barrier, even if its kinetic energy is less than the potential barrier, even if its kinetic energy is less than the potential barrier. So, because of this, the two protons come closer, and the nuclear force bind them. This is the main reason. So I have taken this topic. Now I think it is clear to all you all. I'm just going to repeat the same thing. That is fusion. What is fusion? Fusion is that two light nuclei, they combine to form a larger nucleus, and energy is released. And the example it is given to you. This is the two light nuclei, hydrogen. It combined to larger nucleus, that is 2H1, and it releases positron, neutrino, and 0.42 mega electron volt it releases. Now, uh, inside the nucleus, in spite of high repulsive forces, Coulomb repulsive forces, the nucleus are bind together because of the nuclear forces, which are short range forces. And here, to bind this light nuclei, that is two protons, the two protons must have enough kinetic energy to overcome this Coulomb barrier. So here an example is given in your book, that is the Coulomb barrier between two proton is around about 400 kilo electron volt. And to overcome that, we require 3 into 10 to the power of 9 Kelvin. I have rubbed it to that we require a temperature of 3 into 10 to the power of 9 Kelvin. We require this temperature. So then only the two light nuclei will come closer, and the nuclear force will bind them. Now the most important point here is that this in sun fusion takes place, and the interior of the interior temperature of the sun is 1.5 into 10 to the power of 7 Kelvin, and this temperature is not enough for the fusion to take place. That means this temperature, it can't develop that much of kinetic energy, who the protons, so that they can overcome the potential barrier. What barrier? Coulomb repulsive force. And they come closer to, so that the nuclear forces can bind them. So this is explained by the quantum tunneling. What is quantum tunneling? Quantum particles, any quantum particles can penetrate, that means it can pass through high potential barrier even if its kinetic energy is less than the potential barrier. So because of this quantum tunneling, the protons, because its kinetic energy is less than the potential barrier. So because of this quantum tunneling, it can pass through this potential barrier, and they come closer and binds by uh, the nuclear forces binds them, and energy is released. So in this way, binding takes place. Thank you.